Okay, today we are going to work on reading graphs, and we're looking at a bunch of data on different graphs about airplane A and airplane B. So let's take a look at our first question. Our first question is asking us to read the graph and tell which plane is longer. Okay, so we need to decide which graph is going to tell us about the length of an airplane. And we can look and we can see that graph 1 talks about the length of the airplane. And it talks about the length of the airplane on the x-axis. So I'm just going to drop a little dotted line from both airplane A and airplane B down to the x-axis so that we can see where they fall. Okay, and if we look, we can see that airplane B is closer to longer than airplane A. Okay, it is longer. It is further right on the x-axis. So all of those are good explanations for evidence as to how you know airplane B is longer. Okay, so we can say airplane B, and our evidence is, or can be, one option for our evidence is, it is closer to longer on the x-axis than airplane A. Okay. All right, let's take a look at the next question. We are being asked about fuel efficiency. So let's take a look. Fuel efficiency, it looks like, is on graph 2, and it is on the y-axis. So I'm going to take a dotted line from airplane A and airplane B over to the y-axis. Okay, and then we're going to answer which one is more efficient. Well, airplane A is more efficient. And what's our evidence? We can kind of use the same format from the previous question. It is closer to more efficient on the y-axis than airplane B. Okay. All right, let's take a look at C. Which plane is older? Which plane is older? So graph 3 tells us about the age of the airplane. And then I'm going to drop my line to the y-axis, and what do you notice? They both fall in the same place. So really, neither. They are the same age. Because they fall at the same place. On the x-axis. Okay. Which plane costs more to operate? Costs more to operate. Okay, so we're going to be back on graph 3 because graph 3 talks about operating costs. Okay, so I'm going to draw my horizontal line over to operating costs from both airplane A and airplane B. And we are being asked which one costs more. Okay, which one costs more? Well, airplane A costs more. And how do we know? It's closer to higher costs. On the y-axis than airplane B. Okay. Oops. All right, which plane can fly faster? We are looking at top speed. Okay, top speed. I'm I'm going to draw my line over to the y-axis, and you will notice that they both fall at the same spot, so neither one of them is faster. Okay, so we can say neither. Evidence for our answer: they are the same because they fall at the same place, but this time we are on the y-axis. Okay. Which plane has a bigger engine? Okay, we are still looking at graph 4. Bigger engine. I'm dropping my lines from airplane A and airplane B down to the x-axis, and airplane B has the bigger engine. I said B, right? Oop. Yes, airplane B. Airplane B, evidence. Evidence would be it is closer to bigger on the x-axis this time than airplane A. Okay. All right. Let's take a look at the stories of the graph. Graph 1 describes the relationship between the length of two planes and the maximum number of passengers each can carry. Look at the axes on graph 1 and the position of the points on the graph. What overall conclusion can be drawn from graph 1 when considering the pattern of the plotted points? Okay, so these are all asking you to infer, okay, from the graph. So if we're looking at graph 1, okay, what can we say about the maximum number of passengers versus the size? Okay, so we can tell that airplane A is shorter than airplane B, and it also carries less passengers. Okay, so really what we can infer is we can infer that a longer plane can carry more people. Okay. What overall conclusion can be drawn from graph 2? So let's look at graph 2. We are looking at the weight and the fuel efficiency. Okay, so looking at airplane A, it is lighter and more fuel efficient. So the conclusion that we can draw is that a lighter plane is more fuel efficient. Okay. What overall conclusion can be drawn from graph 3? We're talking about the age of a plane and the operating costs. Okay, so really the age is the same, but they have different operating costs. So there's really not a relationship. So what we can say is that age of a plane does not affect operating costs. Okay, and then our last graph, we are looking at top speed and engine size. And they both go the same speed regardless of their engine size. So what we can say about that is engine size does not affect top speed. Okay. All right, true, false. The heavier plane is more fuel efficient. The heavier plane is more fuel efficient. Well, if we look at graph 2, the heavier plane is less fuel efficient, so that is false. The longer plane carries more passengers. Well, that was actually our explanation in 2A. So that is true. An airplane with a bigger engine can fly faster. Well, we just said that engine size does not affect the top speed, so that one is false. All right.